the location of our game object. So this is where the laser is going to originate from. We are going to want a vector 3 direction. So rather than transform direction, we can just use our dir right here, like this.
Yeah.
And so we're going to be replacing it there. Now our dir, we never told it what it is. VRChat just figured out that this is actually a vector 3 because we're giving it a vector 3. And so we could have typed vector 3 here, but we're super fancy and lazy, and so we can write var instead. And it works.
Var direction. Okay. Oh, so it's okay.
It just tells VRChat to figure it out, and it figured out that we want a vector 3 here.
Very
So we're going to have transformed up position, comma, and then dir. So transform direction, vector 3 forward. We're going to get rid of all that and just type dir instead. So yeah, get rid of all that.
Oh, because it's repetitive code because it already says it up there.
Yep.
Okay.
So now we have that. Now we're going to do out and then raycast hit info. We created this raycast hit, and what this is this is an empty variable that we made that contains hit scan data, such as what did I hit, where did I hit, all that stuff, as well as the normal of what I hit. So you can like figure out, like if you shoot a laser at a wall, you can figure out the normal of it. So that way you can have objects spawn in it and it's like flush with the wall or something. Now, we don't make this equal anything. So right now it's null. It's just completely empty. So over here, inside of the raycast code, it says out raycast hit info. So we give it this null variable and we just type out hit. And that means put all your data inside of this.
Okay.
Now we have maximum distance. We could just type 9999999, but that's a lot of typing. And so instead, we're going to write mathf.infinity, and this will shoot an infinitely long laser.
Wait, math.infinity is scary. We shouldn't do infinite. We should do like 1000.
No, we can do infinite.
Could we do 1000 though, or should we just do infinite?
1000. I'm just going to do infinite.
Are you sure?
Yeah.
I heard that math.infinity is scary.
It can be, but I don't think it's going to do anything bad.
Okay.
Because they'll just shoot the laser and see that it goes on forever, and then it's like whatever. Because it just didn't hit anything.
Oh, okay.
All right, over here, if we go back into raycast, we have our layer mask, and this is the actual layers that we're going to be focusing on. So it's going to go through players, it's going to go through UI, it's going to go through everything, and only stop when it actually hits a thing on the default layer. So now that we have that, we have this is going to return a true and false, depending whether or not it hit something. If it did hit something, we're going to be true. So therefore, we are going to do debug.drawRay, and it's going to fire out a laser.
Ooh, fire a laser.
Now, this laser is going in this direction, and then it's multiplying that direction by hit.distance. Now, hit over here is our raycast hit that we have over here. If you click on it, you can see that it's highlighting it. And inside of the hit variable, it actually has a distance. This is actually how far the laser went before it hit something. We can actually look inside of this if we were to just type hit
local variable.
And we can find all these things. So we can find the collider that we hit.
Wait, really?
We can find the distance.
Hit dot point, hit dot rigid body. Oh, so you could hit a rigid body. So like if you made a laser, every time a laser hits a rigid body, the rigid body gets added a force to it. So you can literally make like a magnet gun, and the magnet gun pushes all the objects away, or it can suck them up because it can add a reverse force on them like a magnet. Holy shit. So you can actually program things.
Yeah, isn't that crazy?
That's crazy. This is what happens when I get knowledge.
Rigid body of the collider if it was hit, and if you mouse over the rigid body one, it actually explains that it will be null if there was no rigid body attached.
Null that means no, right? It's just a nerdy way of saying no.
No, not necessarily, actually.
What's null mean? It means not
null
equal to?
Null means it's empty. So you know empty. When you don't drag something into your udon behavior,
Yeah.
So like if you're looking for a game object.
So it stops it from breaking. So if you have an array with all these lists and it's like put all the objects in the array, but if you don't have one object in the array, just make it equal to, if it's null, do nothing so it doesn't break the code, right?
Because it breaks.
No, null is just there because you have to put something there, and so it indicates that
it's a variable
a nothing
of nothing.
Something. Yeah.
Yeah. So x equals nothing. That's what it is. Okay. Sweet. Yeah.
Aaron's learning.
Yeah. Well, no one ever explains these things. They're just like null, and I'm like, "What's that?" And then they're like, "I don't know."
I don't understand a word anything going on.
It's okay.
Well, if you stand here long enough, you'll start absorbing it. This is like Aaron's like 50th udon lesson.
Like I absorbed udon just from people talking about it, and I don't know it, but that's why I know like Math.Infinity. I'm like something sus about it, but it's okay. I don't have OCD, I swear.
So
okay,
for now, we're just going to get rid of this, and we're going to make sure that this code works.
Okay.
So we're going to want to add one more thing before we play this. You see where it says public virtual void on pickup use down?
Yeah, we just want it to be void.
Let's actually do override void, because that's the proper way to do it.
Wait, really?
Mm-hmm. Virtual means anybody can replace this code. Override means I'm replacing this code.
Oh, so shouldn't we do instead of public material color, shouldn't we do serialized private color?
I prefer to do public because I find it annoying for when I want to reach into something and then I have to go edit the other script to make it public again.
Oh, okay.
It just depends on your style of coding. For me, I'm a very lazy coder, so I just make everything public. Only when you're working on extremely large projects where there's like, I would say maybe 4 or 5 people, that's when you're going to want to start doing serialized private so people don't mess with things that you don't want them to mess with.
I'm worried about hackers and stuff too, but yeah.
No, hackers are not going to be stopped by you writing the word private.
Oh, there's a compiling error. Ooh.
Let's see what happened.
So if I can ask, what type of game are you trying to create or teach them how to create?
Oh, this is using the VRChat SDK, and we're just making it so that you can shoot a laser and change the color on a cube.
Splatoon. Assets, scripts, laser guns.
Do you want me to just give you my laser gun script?
Wait, no, because
something.
Wait. Did I?
Oh, you put fixed update inside of on pickup use down.
Oh, it's not supposed to be that way. So where do we put
Yeah, you're going to get rid of the fixed update part.
Oh, do I put it right here? What do we put for fixed up void fixed up?
Actually, yeah, you can just put it in fixed update. Actually, so that way we don't have to have the player pick it up. So I just leave it.
Where do you have yours at? Wait, where do you have yours?
I was doing it every time the player clicked, but we can do it in fixed update.
Well, we shouldn't do it in fixed update. It should only be when the player clicks.
We can make it so it's fixed update so we can debug it better.
Nah,
if you want.
It's fine. No, it's fine.
This is fine. All right.
Yeah.
So we got this on pickup use down.
And
then we have this.
Yee.
Yes. So now you save it, and then there's one more thing we need to add. Or actually, no, we don't have any code doing this. So yeah, we're just going to hit play. And then we pick up the cube.
I'm gonna go back to my other chat now and hang out with my boyfriend who just woke up. You guys enjoy your udon?
Yes. You too.
Thanks for coming, by the way, Jinta.
I'll come hang out more often, honestly. But you guys are doing your udon stuff, so
goodbye, gender.
We're being smart. We're learning.
I'll hang out again and sleep. Bye-bye.
So, Aaron, we do need to change some settings because we have to make it so the cube snaps to your hand. So, I'm in the pickup script. I'm going to go into here. We need to
sorry.
Orientation, I think we should make it gun. And auto hold to yes. These are the 2 things we need to do. So that way it's less like a beer bottle where you can hold it in any way and more of a gun. So that way it's like.
Does auto hold work in VR or only on desktop?
I think both.
Yeah. It's just desktop. You need to do a specific thing. Well, no.
Oh wait, it's not it's not raycasting. There's no laser. Is it
You would
whenever I
actually want
hold
to look
it,
at the
or?
console because it's doing the raycast for a single frame. So let's unplay it and let's make it so the raycast is continuous so we can debug this better. So that way
Okay.
it's not only on a single frame. So we're going to get all this code that we put in on pickup use down and just put it in update. Public void update.
Oh, so we just do.
That, or better yet, we can just make a public void do laser and then put this in here. And then whenever we
Public
want to move it, we
void
can just
do laser.
do that.
I'm putting it in the scope right now.
Yeah. Now just put all of that code into do laser.
Oh, and then we can just do the put. Oh wait, oops, the scopes got
Yeah.
screwed up. Here we go. Wait 1 sec. There we go.
Yeah.
So this is how come it's squoggled? Oh, cause. Okay, never mind. I know what I'm doing.
Yeah. And now
And
make
then we
sure
can
to
just
do public void update and put the public void do laser in there. Because right now on pickup use down is only called for a single frame, and that's going to make it much harder for us to debug.
Oh, so we got to put a public void update inside. Can we put an update loop inside of this?
No.
Oh, so what do we?
We have to make our own public void update, and then we just put the do laser function in there.
Okay, then
Yeah.
how do we make it whenever you press on trigger is used down
We're
or
going
whatever?
to make it the on trigger later.
Oh, okay. So
For
what do
now,
we
we just want for debugging
Oh,
purposes.
okay.
So now we got this. Let's save it. And so now it should actually work in the inspector, so we don't even need to get the player involved. So now we hit play. No. My laser doesn't love me. I don't know why.
Oh, is it supposed to like show a laser or no?
For me, if you look at my screen, you can see my laser over here is white.
Oh yeah, okay, I had gizmos off. Oh, that's kind of cool. VRChat probably uses this exact thing to select the UI.
Actually, they most likely do.
That's why the UI is like the way it is. Yeah, that makes sense. They probably literally just coded the UI within Unity.
It's almost like it's a Unity game, Aaron.
Oh wait, yeah.
I was about to say. They coded it in Unity. I wonder why.
Sure do wonder.
Hello.
All right.
Hello.
All my
Okay.
besties are coming together. All right, so right now my raycast is not working, and I have no idea why. Let me think. Why won't my raycast work? Won't. Doesn't hit. Let's figure this out. Why isn't it hitting? Yum. Mesh data, map data.
If you read the documentation, you can probably learn a lot from like all these different scripts of how to do things.
Oh, that's probably because Unity really wants people to learn, and so they work on making really good documentation so that people make cool stuff. And
Dude, you can make a whole game just by reading this. Well, I mean, I guess it is a game engine. I don't know why I'm always so scared of code.
I think it's just when you don't have somebody there to like emotionally support you.
Yeah.
Things look
I think it's my inner monologue. I gotta kill it.
A lot less surmountable.
I'll kill my inner monologue.
All right, Aaron, I figured out how to fix the code.
Yeah.
We had to get our mask and remove it because I think I messed up on the layer mask system. So you see how we have a mathf infinity and then a 0? Just get rid of the 0 so it does it on all layers. You might want to hit insert.
It's the most evil key on the keyboard.
Yeah, just get rid of the comma 2. Because right now it's going to get confused. There you go. Now save that, and now your laser should work. It is yellow when it is hitting something and white when it is not. Yes. Yum. There we go. This is also how my rocket jumper works, by the way, Aaron.
With lasers.
Yeah, I noticed that it was laggy to simulate the rocket every frame because everyone's shooting rockets everywhere. So instead, I just made it so you shoot a laser and then the rocket goes across over to that. And then the farther away it is, the longer it takes.
I have a compiling error. Let's see.
Let's see.
It's okay.
I
like when
can
I
you
want
show
to
me
go.
your error?
Wait, no, it's just compiling. It takes so long. Let's see. Oh no, it's working. It just needed to refresh itself.
Now you just need to move the cube around and point it
Oh,
at
it
it.
is yellow when it points at something. It's even yellow when it points there. Oh, that's cool. You can do a lot of cool stuff with it. If only we knew a super powerful shader friend who can show us how to do Splatoon paint shader. Only we knew somebody.
I think a better system might be to actually have a bunch of cubes.
Yeah.
And each of those cubes changes to a funny
Could
color.
you make the graphic of the ray casting different like VRChat does? Like, could you make it like a laser? Because I have a lightning. Can we make it lightning?
Let me think. How would I do that?
Because it doesn't need to be a fancy shader.
I guess what we could do is...
You could just use a decal, actually. I think you could probably just do it with Poyomi.
Oh. Really?
And then you just instantiate a decal object every
Well,
time?
you can animate properties in Poyomi, right? So
I did not know that.
Yeah, so you could just add a decal with the scaling and offset wherever you want on the thing, and you'd have to work out where on the surface it would go.
Oh.
Okay.
I was wondering whether I should do a talk about how floating point numbers work.
Oh, that would be so cool. I would be like the one person to show up.
Well, I think a lot of people would benefit
I would
from
show up. I love hearing Tiny Turtles talk. He has a relaxing voice. He's like a friendly caller professor who doesn't insult you.
Thank you.
But yes.
Okay, I'll actually think about that and maybe put something together that's organized.
Oh yes.
Yeah.
VRChat TED Talks.
1 hour, 1 hour workshop.
Well, just explaining things like, not a number and different kinds of infinities and there's something called denormals as well, which people should probably know about.
Smith would like that too. Smith and Tekkanon would like that.
They probably know already.
Oh. That's right.
I don't know.
They are math people. Me and Templar must learn. Teach us the ways.
Yeah, because I think it would probably explain or how floating point round-off errors work.
That would help for making things Quest compatible as well, because I think there's only 4 zeros you can go with the floating point error on Quest compared to 8 or whatever before it gets scraggly in Unity. I don't know if those are the correct numbers, but I know it trims off half the zeros when it rounds up. That's why you get Z fighting more on Quest.
Yeah, well, it tends to use 16-bit floats, which are not very precise at all.
Yeah, that's what. Yeah. I think it's a proper term, but it shaves off zeros because 16-bit doesn't have that many zeros in it.
Yeah, and the errors that you get look weird. They like errors with integers. It's obvious, it's truncating it down to the next level.
Because it's
But with floating point, the gaps between the numbers are not even.
Oh, yeah, you're right.
They get closer together the closer you get to 0. And there's also another thing where, so the difference between between 0 and the smallest possible floating point number is actually much bigger than the smallest floating point number and the next smallest. So there's this big gap right around 0. And so there's a special thing that they use to fill in this gap, which are called denormals. So I can explain how those work.
That'd be cool.
We gotta, when you do your talk, we gotta record it so that way we can have Tiny Turtles TED Talk on YouTube.
Sure. Okay.
I can have the little TED Talk logo.
Do you
want to
do it Thursday?
Oh yeah. That was quick. Jeez. No, I wanted to prepare and
you're
get
right.
some material together so I can illustrate easily and not just flounder.
Okay.
And I have to refresh myself too.
I also think that rather than moving position of things, the correct Unity way, at least, of fixing Z fighting is changing the render order of things. well, not the render order, but like the rendering groups. There's something in Unity that lets you change the like way it renders so that something will always render on top of another thing specifically, but not on like it won't mess with other stuff.
That's interesting.
And I'm pretty sure that's the correct way to fix Z fighting because
I just make everything gapped apart.
Yeah, but
usually when you
adds,
perfectly
that adds other problems in like very specific cases. So it would surprise me if that's the proper way to fix Z fighting.
All right, Aaron. So you ready for
what do we just write? I just
right.
more learning.
So right here we have our hit variable.
Hit, okay. It's the hit,
right?
And then we're going into a collider.
Yeah, the hit has a reference to the collider, right? And inside of this collider, we can.
Can I pause real quick? This collider does when you type in this code collider, does that work for this right? Oh, why does it take so long for Unity? Look, can you look at my screen real quick? Because this will help me understand. If you hit this is collider, but is trigger still a collider? When is trigger is clicked, is that still?
Trigger is still a type of collider, but raycasts do not work on trigger colliders.
They do. Oh, it stops them. I ran into that problem. You have to put it on a different layer. We'll get to that later. I feel like at the end of this, because I remember there was a problem. I don't want to get off subject, but I know like a solution to that by like layering the thing. But sorry, go on.
So we got hit.collider.gameObject.getComponent. So we have our collider reference, and we're going to get our game object through our collider by doing .gameObject. So now we have the game object of whatever we hit. Here what we can do is get component mesh renderer. So right now we're reaching inside of our game object, and we're grabbing the mesh renderer.
Oh, how come? I'm so sorry again. How come collider comes before game object? In my mind, I would think it'd be game object. It reaches into the game object and then reaches into the collider. How come we're reaching into the collider?
The way our hit system works is we don't actually have a reference. If you type hit.game, you can see that there's no actual reference.
If it hits a collider, then it's gonna search the game object of the collider. Okay, it's like a flow of logic
from here up to here, and then we're gonna go back down.
Okay, that makes sense. Okay, so if I don't interrupt, I won't understand. It'll like. No,
that's okay. I like it when you interrupt because that means you're paying attention and you're gonna learn.
Yes, if I don't interrupt, that means I'm in La La Land, somewhere else in another dimension, in a parallel universe, in a different timeline.
So we get the mesh renderer component.
Yeah.
Right, and so we're gonna look around for here. We're gonna say, oh, here's the mesh render. Now inside of the mesh render, we're going to be getting the materials, or just the material. Which gives us the very first material here. And then we're going to make the equal color, which is this guy.
So what if we have a skin mesh renderer? That's not a mesh renderer, right?
Yes.
Is that different?
For a skin mesh renderer, you're going to have a different use case and type actually skin mesh renderer.
Is there one that encompasses both mesh renderer and skinned mesh renderer, or no?
No, you're going to have to try to grab the mesh renderer and check if it's null, and then try to get this and then check if it's null.
So it's more checks. No, that's okay. I'm not going to use it for skin mesh renderers, but I was just wondering if that was a thing. It's okay, because don't worry about it. Okay.
Because they're seen as different scripts to Unity.
Yeah, and how come these have the Pac-Mans next to it instead of the normal,
greater than and less than equals?
Yeah, those things.
So when you mouse over the mesh render game object or get component, this guy, the way he works is that you want to say what type of thing you're looking for, and that's where you put these two in here. So this is the type of script we're looking for, which is a mesh render script. And then here, this is where we would be putting different modifiers for it, I'd say.
So what do the Pac-Mans do again? So
these guys say this is what we're looking for.
This is what we're looking for. So this is what we're looking for. This is what we're looking for.
Yeah, and you can always look back on this and go, okay, this is how you write it.
Okay.
This is one of those things that you learn.
I think once we find another thing with it, it might click.
Yeah, we can also type rigid body here, and we'll be getting the rigid body. We can type mesh filter, and that would give us the mesh filter, mesh collider.
So do Pac-Mans come after get component?
Yes.
Okay, so that's what the get component will be like. Get component is a Unity variable.
No, get component is a Unity function that returns whatever you put in here.
What do you mean returns whatever you put into there? So it's like you buy cereal and you're like, the cereal sucks, so you return it to giant equal.
Collider,
yeah.
And then you do dot game object.
Uh-huh.
This guy, we already have a slot for inside of the collider. It's already built in.
Yeah, he has a little
component searches for the object and see if it's here, and then gives it back, and then it replaces this line of code here with the mesh renderer it found.
Oh, it's kind of like an investigation. Like they're investigating a house, and he's like has a search warrant, and the mesh renderer is the report that he gives back to the FBI. Okay, that makes sense.
That's the perfect way to describe it.
Okay.
So once we have ourselves this, which will give us the mesh renderer, we'll reach inside of it, and there is a material variable inside of the mesh renderer.
Mm-hmm.
And this will return the single material on the object. This doesn't like to play nice with things with multiple materials. It will still work, but it'll only affect the initial one on element 0. So if you have 5 materials on a game object and you do this, it will only replace the first one. If you actually want to replace the entire material array, you're going to have to do materials, and that will return the entire list.
So material only accounts for 1 material on that object, but if there's like 3 materials, then you're
going to want to put an S after materials, and then turn color into a material array.
Should we do that just to play it safe? Because I feel like there's a lot of stuff that has...
it won't break. It'll just change the first one.
Okay.
Yeah. So
should we code it to do an array of it, or should we just leave it like this for now?
We're going to leave this like it for now, just because that's out of scope for what we're learning.
Okay. Perfect. Good. Okay. Perfect.
We're going to keep this simple. So we got this, right? And now I'm going to duplicate this cube a bit. We're going to make a little cube array. I'm going to actually make it empty to organize it. So we're going to call this cubes. And I'm going to make a little Splatoon map by just duplicating these cubes and moving them over until we have, like, let's say, a wall of them.
How'd you get them perfectly lined up, or just do control?
I just hold control.
Okay.
And I do control D to duplicate. And this is a lot of game objects, but for now, our world's rather empty, so I don't think it's going to matter as much.
You can GPU instance them together, because they're below like 92 polys or whatever.
Okay, so now I have this wall of cubes.
Oh wait, so we can do drawing with it.
That's what we just made.
This is going to be cool. I'm going to put this in a empty and call it painting cubes, just so I know where they all are.
All right, that should be good for now. It's beautiful.
It makes a whole map like this.
A whole map.
Yeah, once I learn one mechanic, I make a map around it. Because if I don't, then I wasted learning that thing.
I'm doing some Nintendo stuff. All right, we made Mario jump. Let's make an entire game around that.
It's like how they think that way too. It's just hilarious. I'm gonna change the color of it to be create.
Yeah, we're gonna be getting a material, and then we're gonna put that inside of our laser gun. And then when we draw, it's going to make it white, and it's going to turn it to that.
And then we're gonna make another one, right? That does like changes it to red. Like let's make it like, what is it, red?
Yeah, red or whatever your favorite color is.
Green.
Yes.
Can't believe I almost turned it
white. So what did you do there? Actually, the GPU instancing.
Yeah, because if GPU instancing should make everything, like if it's under like 92 or 96, It's like if it's under 90 polys, GPU instancing takes a whole bunch of cubes and combines it into one draw call, even if they're dynamic. Dynamic is in not statically batched.
That's cool. I know more now.
Yee!
It's also like anything that has the exact same material, how that happens with.
Yeah, but if it's like baked, then you want it to be static batched. It's kind of cool. I never really. Oh wait, what the heck? It's not working.
I guess it didn't compile correctly.
I think Cyanimu just pooped. No, it did. What the heck?
Whee!
What the heck?
Classic Cyanimu.
Oh, there's no world descriptor? What?
Did you accidentally clap it?
No. Hold on. We're getting to the bottom of this. What's happening?
Let's look at your debug stuff. What does that say? Cannot. Oh.
Oops, my bad.
Like Cyanimu just doesn't feel like it right now. I don't know why Cyanimu just decided to die on you. He ain't feeling too good today. It's okay. We don't need Cyanimu to work this because it works on update, so you can just hit E to get the rotation.
Oh, wow, look at this. Oh, it's so sick.
And hit E to make it so you can rotate it.
Oh, you mean, is that a shortcut key for that?
Yep.
Holy shit.
Yep. QWERT.
Oh yeah, you did tell me that when you first taught me Unity. You're like, hit W and E to use it, and I'm like, that's hard to remember, and then I realized you can just switch them at the top, and then I never did it until this very minute where I remembered what I told you. Why is it turning pink instead of green?
Likely because you have funny Unity shot itself for no reason.
Yeah, there's always a reason. You gotta find it. So I think that I didn't put this. So this is white, but how do we know that the code is telling it to turn green?
Because if you look at my setup here, I suppose.
Yeah.
And let me click on the cubes. So right in front of this guy, this cube is here, right?
Uh-huh.
I think I can actually tell. But this cube over here, we have the white material. If we go forward a frame or two.
You can do one frame at a time?
Yeah, this is the one frame at a time system. So we go here, we move this guy slightly to the right. And you can see it hasn't updated because we have it paused. And now, if I look at this cube here, you can see that it says white in the material slot. We go forward a frame, and I had the wrong one selected, and it changes.
No, how does it know to turn to green? Do we put in a
Because
oh, wait, yeah, you have to put the color in here. Now I bet it will work. Yeah.
Oh yeah, because it was
we didn't put the.
So it was making color null, which isn't usually a thing that happens. There we go.
So I can turn everything green. This is sick. So this isn't like, this is like pretty fun. Like you can do a lot of cool stuff with this, especially with like, if you did with like cool like effects with like shaders, you can make like, what's that shader that Mochi made that's like rips holes in dimensions where like whenever it looks like it's ripping a hole in dimension, we can make it like a dimensional ripper gun. That would be really cool to do. Oh, there's so much potential with this. Yes.
I mean, Udon is Turing complete, so you can do literally anything a computer can do. So anything you've seen in any game ever, you could do with Udon.
Now there's still some stuff you can't do.
There are certain things like the what is it, non-uniform dimensions, non-Euclidean, yeah, non-Euclidean geometry would need to be faked, but
or pre-calculated and then just use a bunch of funny shaders to.
Oh yeah, Templar, you told me about that before. There's a game that you told me about that I didn't understand at the time, but now I do, and I want to talk about it after this.
But Templar, that's also faked. I'd call that still faked because there's ways to do it with like pure math that make it work.
Everything's fake.
But yeah, I don't know why your Cyan Emu is very sad. You might want to delete it and then re-add it.
Yeah, what the heck happened?
So yeah, just go to your project.
We need to call Cyan and ask him.
Ask him specifically.
We want to get Cyan in the Laughing Lizard. We need a planet. We need to get him in. He needs a reason. We can't think of a reason. And it can't be a shitpost. It has to be like a real thing. Because they all know about us.
I don't know why you would want Cyan in there.
He's powerful and he's friendly.
He is rather friendly.
Alright, it's not working, but it's okay. We'll just do it like this. So this is working, which is cool.
Can I ask that if we put 2 cubes behind each other, will it paint again?
What was that?
Paint both of the cubes.
We could do raycast all, and it would continue the raycast even after we hit a cube. And it'll just return an array.
What does this error mean?
Let me look at your script.
Sequence initialized object cannot spawn player if there is no world descriptor.
Not this one, but these ones. So like
serialized object not creatable exception, object index at null.
It looks like he's just not picking up your world descriptor for whatever reason, so you might just need to clap Cyan Emu and then reinstall it. So yeah, go to your assets.
I'm just gonna re-import.
You can delete it in your assets folder, I believe.
There's a way to re-import all. There we go. Then it like refreshes itself.
Oh, I did not know that.
Sorry about that.
I'm learning too.
Cyan Emu is being built into the new SDK, I think, because it was built into the one for the joke jam. Like it was automatically in there.
So you can just hit play and it works.
Which it should have been there from the beginning, but I mean they probably wanted it because they're doing a lot. Yeah, there it goes. So what else are we doing with this laser script? This wasn't even in an hour. That's sweet. Let's keep doing it. Let's keep adding. Let's make it better.
So let's see.
What are we doing?
Let's make a gun that turns static objects dynamic.
Wait, you can do that? What? You can change the if something's static or not?
Not during runtime, but I think what we can do is we can make it so they're all kinematic rigid bodies, and then we turn off is kinematic.
Oh, so it wouldn't actually be baked static.
Yeah.
It's just not moving.
So they'll just be like a bunch of kinematic cubes, and then when the laser hits it, it'll like make the cube come alive.
Oh, so that's
and they'll
cool.
fall from the sky, and so you can go and then just make them all fall.
Oh, that's be cool.
And then we could maybe, let's say, animate those cubes, right, to be like enemies, and they're like flying around in a pattern above your head, right? And then when the laser hits it, it changes the color. It sets it from is kinematic to it unchecks it so that way it can fall and it turns on gravity and all that. And then we can look for an animator, and then we can turn off the animator, so now it is no longer controlled by the Unity animation system. We can turn flying enemies into like destroyed corpses.
Before we do all that, can we make the laser have a graphic, and can we make there be a sound effect whenever it hits something?
Yeah.
Okay, because I want to polish what we have.
How do we make a laser graphic? I guess we'll basically just make it a pen tool and just have the code draw the line for us. That might be the best way to do it.
Would it be with particles or like?
No, it would be like with a line renderer.
Oh, okay. How do we do a line renderer? I'm excited.
So I'm going to make this a child object of the cube, and we're going to go to effects and go to line. So rather than using the particle system or a trail, we're going to be using a line.
Oh, this is a thing?
Yep. It's what the Unity pen tool system uses.
Oh, and we make it a child object of our gun.
So if you look at positions real quick inside of this, yeah, make sure to zero out its position. Yeah, so we got that. Now click on positions right above this right here.
Position.
This is our positions. It goes, the first index by default is 0, 0, 0. And then the next index is 1, which is 0, 0, 1. Right? You might want to leave that at 2.
Okay.
So we have that. And now we're going to set this Z to 5. And you can see that this actually goes out forward.
Oh. What? Okay.
And so we're able to control our line renderer's position like this.
So we can make it 100. So do we make it like 100 or 200 or 1,000 or infinite?
I'm going to make the line renderer actually a separate game object, though, and reset it to 0, 0, 0. Like this. Because this is what I had to do in our rocket jumping game when I made a line renderer. So make sure the line renderer and the gun are in separate, are not child objects of the other.
Okay.
So this way, the line renderer isn't all scuffy. So make sure to hit transform, reset.
Okay.
And this is going to teleport it to the middle of the world.
Okay, it's under the ground, yeah.
Yeah, that's fine for now. Because we're going to be updating it every frame. So now we have our line renderer. So I'm going to get a reference to this. So we're going to be going back into our script. We're going to be writing some code. Public line renderer. And we'll call this line render, but with a lowercase l, because I am not creative. Line renderer. So now I add that. And so now we do the laser, right? And we want to make sure to manage the line renderer and teleport the beginning and end of the line renderer to the origin and then to the hit point. So we're going to be writing that here, right under where we hit it.
Line renderer?
Line renderer, and then we do dot. And you can see here, there is a lot of stuffs, right? What we're going to be doing, is we're going to be doing set position. And you can see it wants an index. So that's like the number of the position. And then a vector 3, which is the final position.
Set position, yeah.
Yeah, so we're going to be doing 0, which will be the first one, because we're math. Or because we're programmers, so we start from 0. And then we want that position to be transform.position, also known as our gun's origin point. And then finish that off with this. Now we're going to be duplicating that. So you can hit, rather than copying it, Aaron, I'm going to show you a cool thing. Hit Control X, or no, here, hit Control C, enter, Control V. Don't highlight anything.
Wait, what?
Hit Control C, enter, then hit Control V.
What?
You didn't even need to highlight it. It does it by line.
What the heck? I didn't know it had that mechanic built in. Okay, sweet.
Yeah, it's nice.
Okay.
There's a lot of stuff like that. So we have this set position 0, and we're going to be making it set position 1. And rather than transform.position, we're going to be hit dot, and then I do believe it's point. The impact point in world space where the ray hit the collider. Because this point is in world space, that means that we would want our line to be outside of the gun. Because if it was under the gun, the rotation of the gun would make it so it doesn't line up with where it hits. So that's why they cannot be a child object. Does that make sense?
Yeah.
Yeah. So we have this. And so whenever that happens, we're going to do this. Now, we're going to make sure to do one more thing. Line render dot enabled equals true whenever we hit something. And then we'll make line render dot enabled equals false when we don't hit anything. So it makes the line just disappear.
But not enable is like unchecking it, right? Enable will be like checking it.
Yeah, so make sure that equals true, not false, Aaron.
Why does it say false on yours?
The bottom one says false because we didn't hit anything. So we want it to be turned off when we're not hitting anything, but turned on when we are.
So the default state is true. Okay. So we would make these.
This equals false. You don't need to set the position when you're not using it because it's invisible, so the players can't tell anyways. So you can get rid of the position for those.
Yeah, I'm gonna have a sleep for a bit.
All right.
Bye-bye.
See you, Turtles. Thanks for showing up.
Yeah, I should do that more. Bye.
Bye. All right, Aaron. So you got that. Now let's save it. And so now what we're going to do is every time we hit something, it'll teleport the laser to our cube, and then make it so the endpoint lines up with where that hit. So now if you hit play. Oh, I don't have a reference to it. I gotta drag and drop it in.
Okay.
There we go. Now it should work. So let's drag and drop our line render into our gun.
Oh, gun. Line render.
Drag then drop that in. Now hit play.
Cyan still pooped. It's okay.
And now you can see the line.
Now the line only how do we know the line? Oh, the line goes on for infinite?
The debug line goes infinite.
Oh, wait, the line only shows when you're clicking on stuff though. The line disappears when it's not clicking on stuff. Can we make the line still appear?
Enable defaults.
We should make the line always appear, but the line changes colors when it like clicks on stuff. Like the line will always appear, because like how are we gonna know if it's gonna aim if the line only appears when we click on the wall? The line should always be on. So the line should always be on as long as you're holding it. So like say for example I have a gun and I'm aiming it, but the ray cast isn't showing only if I aim at the target. So the ray cast should always be showing.
Well, okay, we can do that.
Yeah.
So we're just going to be writing it the same way that we wrote this. So we're just going to copy and paste. We're going to be getting rid of the enable disable stuff, and we're just going to duplicate this part.
Oh, okay.
Now we don't have a hit point because that hit point is defined if it's true, but this is false, so there's no hit point because we never hit anything. So what we're going to do instead is we're just going to copy this part because this is actually where the debug ray goes. So we're just going to copy this. Put there.
Wait, what? We doing? Oh, the transform direct. This part right here.
That, or we can actually just put dir because this is what dir is just these lines. This is just a longer way to write dir.
For this one, right? So it'd be.
Yeah, instead of hit point, just type dir times 1000. And get rid of point.
Oh, okay. So shouldn't we make math.infinity math.1000 since it's only reaching 1000?
We could make it 1000 if you want.
So it matches up with this.
Okay.
Or we should do 1001 just to play it safe.
Why 1001? How is that different from 1000?
Oh, I don't know.
Get rid of math f dot.
Oh, okay.
Yeah.
There we go. Because like if it's 1000, then it makes sense that it only goes 1000.
So we got that. Go. And that's our laser gun.
Templar's like, Aaron, why is he making me change that?
Now if you hit play. Now you got your little doodle gun.
Ooh, the doodle gun.
Now you can paint.
So now how do we make it the doodle gun only appear when you press the hold button? Can we make it an IK system? So you can't move it, you have to use. So this is on an IK. So instead of being a pickup, it's an IK system that you can't move the cube from. Can we do that?
What do you mean?
You're a player.
Okay.
You walk up to it and you think it's a pickup, but it's not. It's an IK system where you have to physically turn it. And the puzzle is you got to color the wall the
so
whole
it's like
wall
those water
with it.
guns at amusement parks.
Yeah! Sorry.
I got you.
Yeah, like the water gun at the amusement park. Yeah, we gotta do that.
Let me think.
And then can we make it so like if all the blocks are green, it opens up the door? Could we do that? That would be cool.
Yeah.
Really?
Let me think.
The actual math for it isn't that bad.
We can ask Everworld. He done some pretty good thing in his world.
Because I'll use this. This would be cool.
Alright.
So it'll be like a water gun thing. Like on an IK system. I want to learn how to do it. They will teach us how to do IK systems. Yes.
Trying to think like what can you even do on your level. Alright.
I can do anything. I'm rilling. I got coffee. I'm caffeinated.
I'm going to be making a capsule here. This is going to be our actual grabby point. Alright. This is where we're going to let the player grab. And then I'm going to have a flat cube.
Capsule. You want a capsule.
This will be the base.
Capsule, and you want this to be zeroed out? Or no, you want it to be...
I'm just building this basically.
Okay, so you want this to...
actual gun.
So you want this to be here, and you want the gun to be like an actual gun, like you want it to be like longer, right? Elongated. Okay.
The line should be under this, and we're going to call this turret.
Okay, and then you want there to be a cube, but that's like a flat box. Okay.
I think there's just a component that works here as well, that just does it once you make that capsule grabbable.
That would be a little bit much for Aaron, I think, at this point.
Try me.
No, it's like one component.
So we have that. Are you recommending the constraint component?
The look at component.
Unity has that? Oh, damn.
So we're lining up this with this.
I've never seen this component in my life.
This might not be the right thing. Oh.
Because we want it to look away.
Yeah, I'm used to a different system that's kind of based on Unity, and the look at component there has like a bunch of offsets you can change.
I'm just going to manually make it.
Yeah, it's not hard. It's really simple math.
Okay.
So Aaron, we got our laser gun, right? I'm going to be making another one, and we're going to call this turret point or something. Unit create E#, and we're going to call this turret. And we're going to be putting this on the handle.
Oh, okay. On the handle. So what is Okay,
and
so the handle is the capsule collider?
Yes, so we're going to make sure the capsule collider is zeroed out on our actual turret right here. So it's all lined up. So make it a child object of the actual gun. Nozzle. And then zero it out.
It got long.
That's what happens when you zero out the scale. Just zero out the position.
Oh, okay. It's like, that's what happens. Same thing with the rotation.
Yeah. So I'm going to move this back now. So now it's perfectly lined up on this one axis. Right?
Okay.
And now that I have that, I'm going to make it no longer a child object.
Oh,
so now we know the gun and the capsule have the exact same positions. Right?
Yes.
And so now what I want is I want this guy to point the opposite direction to this guy.
Wait, should the gun is at -90 degrees. Should the capsule also be at -90 on the y-axis?
That will not matter.
Okay. Sorry. All right. I'm hype. This will be cool.
I'm just reading real quick on what other people have tried. And then inverse direction with quaternion dot inverse. All right, so let's do that. So let's open up our turret script. Yum. Right, and we're going to be putting this on public void update.
Ooh, public void update. Public void update. Public void update. Okay. Then we're gonna make a variable public game object turret. Public.
Yep. This will be the thing that we want to point away from us.
Game object.
So we're going to have the turret nozzle, and we're going to reach inside of it and get its transform. And inside of the transform, there's actually already a
look at. Okay, what's the look at do? Just makes you look at stuff.
It makes that one object rotate, so its blue arrow is pointing towards us.
Okay.
And now we want to give it another transform that it's target. So we're actually going to be giving it our own transform, so it looks at us. And then we want vector 3 world up, so we're going to do vector 3 dot up to give it the up position for the world.
Vector 3 dot up. Okay.
And that gives us space the up direction for world space. So even if it's rotated, it knows what direction to look.
Should we make a variable call it var or dir vector 3 dot up so we don't have to keep writing it like we did before with the public variable, or no?
It would actually be easier just to put vector 3 dot up.
Oh, okay. I'm just asking. Yeah.
It'd be one less line that way.
Yeah.
So we have this, right? And so it's going to now, if we hit play, it would actually turn this towards this, and that's not what we want. Right? Okay. And so now what we want to do is we want to change the rotation of turret nozzle to, I think I accidentally built this script. Oops. I want to do turret nozzle dot transform dot rotation. And this will give us a quaternion. A quaternion is the unity rotation of a game object. And we're going to be messing with this. So what we can actually do with this now is we can actually type quaternion dot inverse. And this gives us a function that returns the inverse, or the exact opposite, of our current quaternion rotation. So now we just put in our current rotation. And now we are setting our rotation to the inverse, or the flipped over version of our current rotation. So this way, we don't actually have to know about how quaternions work. We just use the function that does all the complicated stuff for us. So we make it look at our actual bean, and then we flip it over.
Okay.
And we do this every single frame. So now if we save it, and go back into here, I'm going to make sure this has a pickup script on it. And make sure it's set to is kinematic so it doesn't fall to the floor.
The capsule?
Because it's going to be our handle.
Okay. Is kinematic and has a collider.
And now it should have it.
Wait, how do we constrain it if it's a pickup? How do we make it the IK system?
And we just drag and drop our turret gun into the turret nozzle.
Oh, we have to put the script on. We have to put this. Okay.
Convert it to a Udon behavior, and now drag and drop.
That hasn't constrained it yet. That's just to make it follow it.
Okay.
And so now, if you were to hit play, the position of the actual thing will rotate this object.
Oh, funny scaling. Non-uniform scaling, baby!
You got to actually move it.
Oh. Oh, interesting. Oh, wait, so it is faking it. So it follows it from math. That's interesting. Well, it's not really faking it, but like I get how it works.
And if you move it up and down.
Non-uniform. Yeah, it's not doing.
Interesting. Why are you like this? I trusted you. Maybe if I change the scale back to 1111. Why is he flat? Oh, it's because the turret down there is flat.
Is flat.
Put that in there. Lamau. XD.
Oh, no, no, no. That wasn't.
Alright, now if I move this around, I have no idea why it's being like this.
So you have something scaled. Oh no, why it's looking the wrong direction?
It looks like it's doing it in world space, maybe?
It's inverting the coordinates.
Yeah, it's because it's in world space. One is in world space, the other is based on local space.
So we have to make them both worked on world space, or both made on.
They have
local?
to use the same coordinate space at the point where it has the actual math. Otherwise, it causes problems.
Oh, that makes sense. I just don't. Where do we put that?
See what the actual lookat is doing then. I'm gonna get rid of the inverse just so I can understand what's happening. Someone comment that out and just study this.
Should we apply the transform of the object of the gun?
Yeah, there you go. Now
so
you want to just
you
rotate it on the up axis.
On the up axis?
So you want to rotate the up axis 180.
Alright,
no, sorry,
rotate it around the Y.
And what if we make it so it's the negative blue arrow what is shooting at?
Yeah, I guess we could just make it so it shoots out the other side, and we just make it look at that so we don't actually have to flip it.
Yep.
This is genius. Look at this.
Either way,
we got professional coders.
Wow.
It's not really professional coding. It's just
professional coders. All right, Aaron. So let's go back to our script.
It's hacky bullshit, and I feel like that's what people. If they just
who needs to know how to actually rotate things? That's lame. All right, so we're gonna get rid of the second line, Aaron.
Actually understanding quaternions? Nah.
No. So now this is going to, if we remove the second line, it'll just look at our bean, right?
Okay.
So if we go to laser gun.
Okay, laser gun.
You know how our laser gun, for the dir that we are using, it's shooting out forward. If we add a negative, it'll shoot out backwards.
Okay.
And because we used dir for all of these, it's going to work. But you see how this isn't dir?
Yeah.
We're going to want to replace these with dir. So that way this is going to also be correct.
Oh, so if it's like the variables are kind of like prefabs in a way where you can just
they're like little coder prefabs.
Okay.
So replace transform direction dot vector 3 forward and replace all that part with dir. So it should be at the end dir dot hit distance.
Wait, hold on.
Get rid of transform dot transform direction. Get rid of all that.
Hi, Spider.
Bye, weeb. Yep, and now make sure it matches down there as well.
Oh, wait 1 second.
Dir dot hit distance. But instead, we have times 1000. So just do dir.
How come we didn't do this in the first place? Or was it just because of the code that we got online?
It was just the code we got online. This is what it should look like.
Okay.
Those two lines do the same, but dir is just way easier to write, and now it's a prefab. Aaron? Hello? Aaron went quiet. Hi, Spiderweeb. Aaron went quiet. By the way, body cat player.
Yes.
I always thought your thing wasn't actually a scary animatronic mouse. I always thought that it was a little kid in a hoodie and he has his arms in the air. And I actually haven't looked at it close enough.
Well, big
Now I
surprise.
can't. Now I can't
It's
unsee the
Lobit.
actual thing. I always thought it was some kid with his hands in the air and he was adorable, and I'm like, oh, he has such a cute logo. Aaron went quiet.
Guess he died.
He's looking at his mic settings. He's opening and closing Discord.
Okay.
Spider, we were learning code. By the way, I never asked, but Seth or Seif, how do I say your name?
You just say, and if you're close enough, it's good enough for me.
Okay, Senor Sidoof.
That works. I'm good with this. There's only one that makes me slightly angry, and, when people call me Selfie, because there's no I and the E in that order.
Hey, Chappelle! All my friends are getting together. No one joins these my Discord, and now everyone's showing up. It's so nice.
Can you say hi?
That's cool. Yeah.
Also, I think you put the wrong time on the event, just so you know.
No, I put a time of 1 p.m., but then I got bored waiting for it, so I just did it now.
That's what I'm saying. I think it's the wrong time, so that's why people are joining now, because now is when it actually starts.
Oh, here we go. It's back.
Actually, Templar, when you made the event, you actually set it to 2 p.m. So people
What?
think the event start at 2 p.m.
What?
Yeah.
What?
Yeah.
Hold on, I'm back. Can you guys hear me? Can you hear me?
Yes,
it was 1 p.m. You didn't specify the time zone.
Yes, we can hear you.
Yeah, time zone.
Yeah,
we
you
can
have to
hear
put in
you.
the description the time zone so that people
No. The Discord events already changed their time to your time zone.
Rule, I'm back. Can you hear me? Hello.
Yes, we can hear you.
Oh,
no,
sorry.
I'm just talking about, because, Discord events for Laughing Lizard in the description. I always put in 1 p.m. EST, this time PST.
So people don't have to translate it themselves.
Correct.
Yeah.
Oh, that's so nice.
I got where it says dir, D-I-R. It was the last thing I did, and then my internet cut out.
Dir equals negative transform, not forward. So this is actually going to shoot out the butt of the cube.
Okay.
But the cube is going to be facing the actual capsule and shoot out its butt, and that's going to be the laser.
Okay.
It was my first and probably last clever saying.
So Aaron, can you share screens?
Yeah. Oh, am I not share? Oh, yeah, I gotta do that again. There we go. Here we go. So if I take this, if I rotate it, it does nothing, but if I move it, okay, so now it goes like this and it goes up. Okay, it's working. Yeah, there we go. We just gotta constrain it somehow. Oh, this is perfect. Yeah, it's doing it perfect. Okay.
Nice.
Okay.
Now I just need to puzzle out why mine isn't working.
It's not? What the heck? Let's check it out.
Yours is. Oh, I guess it's because the line is a child object of turret, and turret isn't at 0, 0, 0.
This would be kind of cool to make a maze, like there's some blocks you're not supposed to hit.
Yep, there we go. My cube is not shooting out its butt, and I have no idea why. Do the laser out of that.
It's had a nice morning for a few days now. Have you had a nice morning every day?
Yes, actually.
That's good. I'm glad to hear it.
I've been doing a lot better as of late.
Hell yeah, that's what I like to hear. Good stuff. Yeah. Awesome.
Let me hit play, see how it works. Did I just forget to save? Yeah, I just did. Alright, so now we have our little laser turret.
Okay.
And now we can draw by moving this little bean around.
Yeah. But now how do we get the bean to be constrained to an IK
What do you mean
system?
constrained?
Like an IK system. So instead of like, so you don't run away with the bean, it just keeps, remember how like with your gun, like the IK system where like you hold the thing, so you can move the thing around, but it won't move away. Like it's constrained within the square, so it can't move. The bean can't move out of the square. You gotta like
People
turn it
can't
around.
steal it.
Like, you know those things at the water park that you like hold and you can't run around like with it like a squirt gun, but it's stuck on that thing and you can move it around and squirt the gun, but you can't move it off the rail. Do you know what I'm talking about?
Let me think about how I do that.
Yeah.
So we just basically grab the entire construction and move it in an epsilon.
I have one way of doing it, Aaron.
Yeah, you did it before with your things, yeah.
The way that I did those is I have a pickup object that you can run away with. And that one isn't perfectly invisible, but the player can pick it up. The one that you can see that is visible is not a pickup object, right? And so
we wouldn't make it a pickup.
The player would pick up an invisible capsule and run away with it. And when that invisible capsule is super far away, the visible part of the capsule actually just stays behind. And when the player drops it, it just teleports back.
Oh, can we do that? That would probably be good. Yeah, let's do that.
That's how I do it.
Yeah, I want to learn how to do that. Let's do it. Let's do it. Let's do it. Let's do it. Let's do it.
All right. So this is going to, I'm going to be doing some changes. So just follow my changes.
Okay.
So this VRC pickup, I'm going to remove.
Okay.
I'm going to be going to the gun part.
The gun
and
part.
I'm going to be removing this VRC pickup too, because we don't want players stealing the actual turret part. So now we have no way to pick up any of this, right?
Uh-huh.
I'm going to be renaming capsule to handle. And I don't know how to spell handle. Is it L-E or E-L?
I don't think I'm cognizant, really.
I'm going to do both. So now that we have handle,
it's okay.
Have fun, guys. See ya.
Bye.
Bye. So we got that. We have our handle, or I guess this can be just our handle visual. So this will be like a handle that the player can see. And then we're going to create another, and this one, we're going to do another capsule. And we're going to make sure to reset its transform as it's a child object, so they're perfectly lined up.
What's this? What's the next handle called?
I'm going to remove the visual, and we're going to call this pickup ghost. Because this is perfectly invisible, but the player can still pick it up. So VRC pickup. And we're going to make sure this is kinematic.
Oh, okay.
So the player will pick this up and try to run away with it. And this guy will stay behind.
Pickup Ghost has Capsule Collider, Rigid Body, and Udon Behavior with gun script on it, correct?
No, the Ghost won't have anything but Capsule Collider, Rigid Body, and VRC Pickup.
Oh, because you have VRC Pickup on it. Oh, Pickups. Okay, never mind. Okay, Pickup.
And now we're going to be going to Handle Visual. And this is where we're going to have our code.
And Handle Visual has
this is not going to have a collider.
Oh, okay. It doesn't have. Okay. But it has the Udon Behavior with the gun on it. Okay.
Yeah, and it's going to do all our thinking for us.
Okay.
How do I want to do this? I'm thinking of just teleporting to our ghost.
Mm-hmm.
If the ghost is within a certain range. That's my theory. So we're going to do public game object, and we're going to call this pickup ghost. And then we're going to make a var dist, and then we're going to do vector3.distance. And then we're going to be putting in our turret nozzle, .transform.position, and our pickup ghost, .transform.position. And this will give us the distance between these two.
Actually, you might not want to make it teleport if it's within range, but you might want to make it teleport to the range and try to also like basically so it makes a line between the box, the capsule, and then the pickup ghost. just because otherwise it creates situations where it doesn't like feel correct. I would bet. Just letting you know. I'm right though.
Because if they're just outside of it, it just finds the distance between them and makes sure that it's clamped at that distance. You think? To make it feel nice. How would we do that? I guess we can get a direction between them and then normalize it so it's exactly 1, and then we use that as the teleport point. That could work out nice. Okay, let's go var_dir, so this will be our direction. And we can subtract their positions to get an arrow in space. So now we have a direction. And now we're going to want to make sure that this direction isn't the actual distance. Because if we were to use this and to teleport our boyo, he will just go all the way over there. So what we're going to do is we're going to do dot normalized. And this will make it so no matter how big this number is, it's going to stop at 1. So it'll be clamped down to 0 to 1. And so now what we can do is...
What does dot normalized mean? I'm sorry.
Let me get my NASA program out.
Yes. NASA time.
So
Lesson
here
8,
we have our game object.
NASA.
Right?
Yeah.
And let's say here's our secondary game object.
Yeah.
Right? And we're going to draw a line from here to here.
Okay.
Now, this line that we're drawing is, let's say, this is our radius, if we had a radius of, let's say 1. So this is 1.
Yeah.
And this goes out to like what looks like 3. But we don't want this to actually go all the way over here. So what we're going to do is we're going to do dot normalize, which basically makes this line and it cuts off this part at the end and makes it so it's only a length of 1.
How come so many words in code use the word normalize and normal and normals? It's okay.
I'm not sure.
I wonder what the word normal even means. Yeah. Okay. There we go.
A normal, by the way, Aaron, is you know what normals are on squares? They're just like little arrows that show where the face is pointing.
Yeah.
So we got that.
Yes, the unit circle. Yeah, you've got this. You know what you're doing.
Yeah, we got the unit circle going.
Good
so
man.
Now you're set, Aaron.
Oh, so normalize means that it's cutting off from the dot to the circle, which is that arrow going out instead of...
We're getting rid of all this.
All the green. Okay, so it's normalizing it.
And
oh, okay, so it cuts it off. Okay.
Yeah, and it's only going to be a distance of 1. And this is 1.
Okay.
So you can only go 1 Nanachi away, and then it will just teleport it here rather than teleporting it here. Aaron disconnected. Lamau. You disconnected. LMAO. 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 Alright, I'm gonna start just coding up all of this now, and we can just dissect it. Time to start writing code. So we want the nozzle. No, we want to teleport the ghost around. I guess our cells around actually. Transform.position should equal the ghost.position or .transform.position. Hey there, Aaron.
He's got a pretty bad internet right now.
He's trying his best, and that's what's important. What is going on here? Okay, it works when it's positive. Why does it only work in this quadrant? Because in this quadrant, it works perfectly. But then when we go into another quadrant, that one quadrant works. What about this quadrant? What? Okay.
Also, can I ask why you're doing that? Because you could just have the ghost object and have it pointing at the correct direction. Like, anyway. Also, it looks like your actual object there is going to the wrong location.
Yeah.
That's why it's. Did you do the math correct when it's too far away? Oh no! Is it around the base that it's doing it now instead of the actual turret? Like.
All right, when it's close, it works.
Yeah. So the math when you are like doing the teleportation thing is incorrect.
Because right now this is just setting its position to dir. No, this is the one that we're doing. So if it's under 1, so it's this one that's not working. Why? And restarting his computer.
What is dir here?
Dir is direction.
It's a direction from the turret to the ghost.
Do I have this?
Hello? Oh my goodness, I'm so sorry, my internet. Okay, it's good now. Can everybody?
It's okay. We're still figuring out the code of what we would even need to type in. I'm just putting in random variables until it works.
See, when you drag it out of 1, it teleports the actual object to the ground level.
Okay, so that looks right, but now it's positioned incorrectly.
No, wait, maybe we need to add the. Because if we go look at the turret and we turn this off, and then we click this.
Are you doing spherical or circular math here?
I'm thinking actually, if we were to move this down, it would be correct. That's our problem.
That's what I'm betting. Yeah.
Yeah, so we just need to add the actual position of this capsule. Yeah, so here it works.
Yeah, so it was positioned around the wrong place. So you need to just.
So we need to add its current position to this.
It's Y. It's local Y, I think specifically.
So dir plus.
And you don't actually have to do that if you just move the whole turret like thing, and instead reorient how you're thinking about it.
You're too wise.
Because right now your like turret like thing, the actual gun, is locally moved position, and that's why it's causing this problem.
All right, why is he being silly?
I think because you're using the ghost position. Yeah, you're using the ghost position. That's why it's happening.
Rather than the hand visual.
Position. You want to use the LE gun position.
Le gun. So you want to use
finally it opened.
The gun's position to do this rather than the ghost.
The ghost. Yeah.
So we're gonna go turret nozzle. I'm gonna rename this one to turret nozzle actually, rather than like gun, so I can actually tell what's happening. No. Hit play. And now, if we pick up, this one is the pickup script, yep. It's so nice having smart people in this call.
Yay.
Yeah, so people can now mess with the gun, and this clamps even if you try to run away with it. But it doesn't seem to update it. Unless it's close. No, wait.
When it hits the player, it's still.
Oh, I think it tried to grab the player's collider, and that returned a null, and that broke it.
Ah, yeah, that's very likely.
Yeah, so we'll have to do a null exception check, but otherwise it should be fine.
Gotta love those funny sentinel values that aren't described or declared in the type system.
Woo, I don't understand.
Sentinel values are things that are returned when there is no other value to return. So things like nil or -1 when the actual value can literally never be -1.
All right, Aaron, so this is what we're going to write. All this. I can just DM it to you, honestly, and then we can explain it.
Where'd you get it from? What happens? What's going on?
I did a lot of testing.
Oh, cool.
They just changed the values until it worked, yeah, basically.
Okay, I see. So you did math algorithm. And that is
Public
going in the turret or the...
Yeah, this is going in turret. Public
Where
float,
at? Is it getting replaced with line 14 through 17?
Here we go. How about this? I'm going to just send you this. We're going to make this equal to.
Oh, it's in the void.
Put
Okay.
this in here.
Oh,
don't
I
put
did
that
it.
one. Put this one. I'm going to just replace it real quick because I changed one thing.
Oh.
There you go. Now we have a slider.
It broke.
Let me look at what you're doing.
Oh, wait, never mind. I did. There we go.
Yeah, now paste it. Hey, it's beautiful.
Perfect.
Yep. So now we have that. And so now if you hit play, it should just work. So if I were to get the pickup ghost and move it around, move it up and down.
All right, there we go.
You're going to want to change the actual distance it locks to so that it doesn't do the snap thing it's doing.
Turret nozzle. What's the turret nozzle? The gun? Or what's the nozzle? Oh, the gun.
The nozzle is the gun.
Oh, should we call the gun the nozzle then?
Yeah. Because I'm just thinking of this. So this would be position, clamp distance. Yeah, and then we're going to multiply direction by clamp distance.
Sweet. Be right back. Be right back.
And I'm just going to send this to Aaron. There we go. And so now it will no longer snap. Yeah, and so now I have a drawing gun. Ain't that rad?
It still dies on the player.
Yeah, we gotta change that. So that when we do this, it doesn't break. Like that. Yeah, so I'll just check if it returns a null. I guess. If hit equals null.
I'm back. Sorry, I have eggs. Okay. Sorry I made the whole thing way complicateder than it had to. I thought it would be like an IK system you throw on and it's like boop. I thought it like Unity had it built in. Hello? Oh, I'm back.
Hello.
Oh. Yeah, I thought it would just be like a drag and drop for the IK system. I didn't realize you had to do. It made its scope huge. It's okay.
The line of which things go from easy to infinitely hard is a very, very wiggly one.
Yeah.
I want to make it so that we can see if... Oh, how did the meme go? I want to see if we can make it so every photo someone takes in this park, at what time. That's going to take like maybe a day in a programmer. All right, and I want to see what type of bird is in each of those photos. That's going to take, I think, 2 years and a team of neural network engineers.
That's a good way to scope out, especially for a commission when someone's like, oh, I want it to be this. I'm going to tell them that exact statement that you just said.
Wait, what? What just happened? What was said? I didn't hear it.
Okay, so the joke goes, all right, so I want to make it so if somebody posts a photo, I want to see what time it was and if it was in this park. All right, that'll take me a data program. Cool. And now I want to know what type of bird is in each of those photos. I'm going to need 2 years and a team of neural network engineers.
God.
Nuts.
Exactly. So, Aaron, did you get the
If hit dot collider equals null return?
Yeah, so this is if it hits the player,
Uh-huh.
we're going to return, which basically means skip everything in the rest of this function. So if it runs into this, it's going to skip all this code.
Okay.
Because it broke whenever we pointed it at the player, because the player is protected. So if we try to get the collider, it just returns a null, and that breaks our script. So here, if it gets a null...
Wouldn't it just ignore that? Why don't we just code it to ignore the player?
This is ignoring the player. If it hits the player, it's just going to do nothing.
Oh, shouldn't we do the ray cast is only on a specific layer, though?
I tried that. It broke.
Technically, that's ideal, because if the player stands in the way of the beam... Actually, in this case, it's not ideal, because you want it to not paint if the player's in the way.
Okay. Because what I would just do, put it on a new layer instead of the default layer. So, like, have all the objects on new layer. Because I think VRChat protects its layers or whatever with certain things. Because they have their own collision matrix, so you have to make your own collision matrix for that.
We can get a layer matrix going. So public layer...
I mean, not like in there. I would just test to see if it worked on layer 22. Oh. All
right, let's just do layer mask then.
Oh, okay, cool. Learn more.
So do public layer mask,
Public layer mask. Okay. Layer mask. Okay.
And then we're gonna put this right after the 1000 right here.
Oh, you have it in the middle for some reason.
No, this is completely arbitrary.
Okay. So layer mask would be in the hit. Oh, okay. And then we would do.
I want layer mask.
Okay, cool.
Now that we have that, right? If we go back into here and we look at our script again, see where it says layer mask? Nothing on our.
Oh, I didn't know you could do that. Yeah. So on the nozzle, it says layer mask, so you'd have to put which layer we want. And I'm gonna, why don't we do this for the bear duck gun script? That would be so much easier when transferring it to a new world. So if I give you my project and you have every object on layer 22 and you're like, I have code that affects layer 22, I need it to be layer 25, use a layer mask to switch it.
You can also select multiple layers with this system.
Oh, what?
We're just gonna leave this on the default layer.
So it can be mixed. Works. Okay. I'm gonna make the painting cubes on layer 22, I mean. It's gonna be on layer 22.
Alright. So you don't mess up anything else.
Yeah, I'm just gonna make it so it only paints on layer 22. Yeah. Oh, it still works.
The players can't repaint the entirety of the laughing lizard.
Oh, it snaps back. Oh, okay. I see what this does. Oh, so this would be kind of hard. Oh, no, it's okay. I get it. Yeah, there we go. So it won't affect the floor.
Did you update your turret script, by the way? Because we made it so we adjusted the snapping. I sent you a new script for you to copy and paste. in your DMs.
Okay, snap.
Snap,
Is this
snap,
the
snap.
turret one right here, the void up, the public?
Yeah.
This?
We just, yep. Then maybe get rid of the duplicates. Yeah.
Okay.
There you go. And now that is our code. And so now the position of pickup ghost determines the rotation of this guy. And then when you try to bring it too far away, it just stops following. But even when it's far away, it's going to still try to point towards it. And then you can customize what layers it lands on and all that.
Oh, okay. Oh, wait, it does kind of work. So wait, so pick up. Oh, that's kind of cool. What? And then like, so what? Oh, no way. So it goes away. So what happens if you let go of it? Does it stay in space or does it snap back?
We're gonna need to make a script on drop. Just make it teleport back to the actual handle visual when the player drops it.
A new script or in the current one?
We're gonna need to make a new script. This one's gonna be a short one though.
Okay. U sharp, and what we're gonna call it?
Snap on drop.
Sorry.
Exactly. So wise, Aaron. On drop. Public override void. Public game object.
This is a perfect example for
Snap
on pickup on use. Pickup use. Oh, on drop. Oh. And then we would
So when the player drops it, its transform.position will equal the snap point. Dot transform.position. And so when the player drops it, it'll just teleport back to the actual thing. So the player can't lose the invisible thing. You might have misspelled snap point. Yeah.
Oh, that's easy.
So now let's go back to our pickup ghost, and we're going to be adding.
Theoretically, could we put this script on this turret script, or no? We don't want to do that.
Oh yeah, we could put it all in one big Omega script, but I think this is easier. Because let's say you wanted to edit one part of it, you wouldn't have to sort through everything.
Okay.
It's better to have more scripts than to have one 900 line script.
Okay.
Because then it's less confusing. Because people can hop in and go, okay, this is the gun part. This is the actual aim constraint part.
Yeah. So this
and
nozzle.
It's all separate.
Oh, so the line renderer be inside the turret as well? Okay. I see. Line. So the line will put
when the turret has the weird bug that we are going to need to fix. So everything works when the turret
so the pickup
is at 0, 0. But when I move the turret, look at this.
Should we have the snap ghost and the snap point? Handle visual. Do we have a script on the handle visual?
No.
Oh.
Maybe. Yes, we do.
Okay.
This is how I have my setup. We have the pickup point right here. This is the pickup ghost. Right? Here we have the handle visual. This is what the player is going to see. Here we have the actual nozzle. This is the thing that's shooting the laser. This is the line renderer. And this is the actual cube that the turret is sitting on. When we move the cube, though, this guy starts bugging out the line. So I actually might want to adjust the line renderer code. Seth, what do you recommend?
What's the goal here?
When I move the turret, the line renderer is funny. See?
Looks like you're adding a position of something. Yeah, it looks like a coordinate space issue.
Impact point in world space. I guess impact hit dot. The collider that was hit. for point impact point in world space where they hit the collider. I'm gonna probably want to set up a matrice or world space to local space unity. But that isn't a transform. This is explaining what they are, not how to hop between them. Doing Googling till I figure stuff out. So they recommend. All right. And then I put this, and this should fix it, question mark? I forgot to unplay it. No. Let's save it. Let's see if that fixed it, actually. I am curious. It's in the bug fixing stage. The turret? That made it worse. Ah.
I think what you copied, it's actually a link for a website too.
Ah. It links us to the Unity docs of the same thing. Camera relative point. Camera relative point.
Templars being forced to learn.
I'm not sure. How to fix this. Actually, is there just a do everything in world space checkbox in the line renderer? That might be way easier. Alignment, view, texture mode, stretch. Use world space. Hey, I don't need to be smart. There's a checkbox. Hey. Who needs to be good at code? That's what I thought. Yep, so Aaron, I figured out the bug.
You did?
Mm-hmm. So okay. Go to your line render and check use world space.
Line render?
Line, and then check use world space. Up the checkbox.
Oh, okay.
Yep, and now you can move it anywhere in the world, and it should just work. And you can make it. This honestly should be it now. No, the rest is just polish, like adding a little laser sound effect or whatever.
Yeah, so it mean it will work. Oh, that's cool. Yeah.
I'm going to be removing the everything from the turret, and I'm just going to call this turret.
Ooh, how do we make it so if when a block turns green, it makes a sound effect? I feel like that
we would probably want to make it so we check if it isn't green, and then if it goes from not green to green, then we play a sound effect.
Okay.
And we would probably want it to be in world space, so we're going to be make a prefab. So let's find a snazzy sound effect. So let me go to my sound effect stuff.
Ooh, when you find
Unity, free sounds, probably. No. Laser.
I think first we might try to search for splash.
This is deafening.
If you want to add
That's
the
hot.
sound for the cubes.
What?
If you want to add the sound for the cubes, I think we might go with splash.
A splash?
For the cubes, when they turn green.
So like a little particle effect and everything?
I think we can do that too, but probably I won't going to do that. Since I'm a Linux user and I can't even run the program.
Aaron, let's make a little fun thing now.
Yeah, fun thing.
So
can you throw me that sound effect?
Yep.
Yeah.
It's a cute little one. There you
go. Alright.
So I got this. Quick laser.
Thank you.
And I'm just going to throw it on a game object, and I'm going to use a VRC spatial audio source and all that.
So we're gonna put a audio source in the turret then. Okay, audio source.
And play on awake would be fine. And set spatial blend to 3D. And so now we have this audio source that's going to play instantly as soon as it spawned in. We're just going to call this effect. And I'm going to be adding a particle system to this. Particle system.
Oh, okay. What do you have a particle system?
Give it the default particle system particle. And I'm just going to play with it. Turn it into a sphere.
Oh, it's shape.
Let's make it, instead of over time, we're just going to make it instantly do like 100.
My PC is going to die from that. Yay.
And then we're going to do the simulation.
Wait, for emission? If you put 0 on the emission?
Yep, so that way it
Wait, let me see what it looks like. I didn't know you can do that.
Yeah, you go to emission and then you set 0 and then you make it burst 100.
Oh, where's my, I don't have a burst thing. Oh, okay. Oh, wait, what's a burst? Burst would be count 100, so you just do 100
So it'll
at
spawn
once.
100 on frame 1 and then never again.
Oh, maybe I should do 10, 20.
Set this to teal.
20, and then you set the
I'm going to make it die really quickly, so lifetime, we're going to set this to 1. So it goes
start lifetime. And then you
shape,
did like...
I'm going to change the radius to 0 so it starts from a really thin point. Just
oh, you're really good at this. I didn't know you knew how to do
speed,
that.
let's turn this 5.
And maybe we can add it too that it fades away. So not just disappears but fades away.
Fades away?
Yes, so not just disappears but fades away. In a short period of time, but fades.
Can you just make that a prefab and send it to me?
Okay.
I can't speak English.
No, that's okay. I think it's pretty good.
External forces, rotation by speed, rotation over lifetime. Let's do size by size over lifetime. Let's actually have this curve go the other direction, actually, Aaron. Let's have this go down. See how that looks?
Yeah, something like that.
Perfect.
Let's move this up so I can actually see what I'm doing. Let's do color over lifetime too. So let's start this off with a nice green, or no, a nice bluish, and then have this fade to a nice greenish. So then we have teal for the most part, but then we're going to have it fade out. So we're going to crank down the alpha to like, let's say that, and then add another alpha mark over to here, cranking this up, leveling it a bit, and leave this alpha here at 255. Don't need this many alphas. I want to see what I'm doing. That's cool. And then I guess, yeah, that should be good. Let's add a light to this too. Because it's only going to exist for a second, so I think we can have a cute little real-time light, you know. We're going to set the radius to something tiny, like 1. And so this will be the effect. So it's going to spawn at a wall. Let's turn the intensity to something that we can see at all times. So then it'll be. Yep. Shadow type, no shadows. And so if it's in the wall though. Yeah, so we're going to want it to spawn just a little bit away from the object that we hit, like this. Right, so we don't want it to be in here. We want it to be over here. So that way it actually allows us to see stuff. And we can assume actually that if this is actually going to be here, we can assume that the particles can collide with stuff. So we can turn on collision. And then make it so they have a high bounce. Just like 2. And we want things to collide with the world.
Oh, it's so cool.
We can maybe add a little bit of gravity to it.
Add a little
So
gravity,
it looks more realistic.
Or add gravity or remove gravity?
Add a little bit. So it's
like
going
1.
downwards.
Oh!
The negatives.
Oh, like they just bounced off the floor. Boom, boom. All right, let's turn off the bounce then. Or let's turn down the bounce because it kind of just went up. Where is it? I can't find. This thing is so complicated. I love how flexible Unity systems are, but like, goodness. Calm yourself. 0.1. Doom. Alright, that's no fun. 0.5. Doom. 1. Doom. 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 Doom.
What if we reduce the
Let's turn down the
gravity
gravity
to half?
Gravity modifier 0.1. 0.3.
Oh, that's good.
Let's have a start velocity actually. So, where is it? External forces, collision, trigger, sub-emitters, lights, trails, custom data. There should be a start velocity that we can work with. Velocity over lifetime. Limit velocity over lifetime. Inherent velocity. Force over lifetime. Man, there's so many toys here. Goodness. Size by speed. Rotation. Rotation by speed. External forces. Noise. What happens if we do noise? Oh.
So let's randomize the direction.
Let's turn down the noise to like 0.1. 0.3. How do you feel about this? I guess I can crank the velocity, the start velocity.
I'm just surprised how fast you did that.
Start color gravity simulation space. The hardest part is finding all the buttons that I want to play with.
I think it's fine for now.
5. No, let's go 3.
Oh wow.
There we go. So now I have this effect, and it's all just nicely packed into one.
Could you just throw that at literally like the effect in the asset folder, and then just throw the
What is it? You hate it? Fine.
No. Yeah,
Gone
you just
forever.
make the effect the and then just throw the prefab into the DMs. No, you don't even. Yeah. Oh, perfect. Yeah, and then just throw in the DMs and it will work.
All right, here have.
That's what's cool about just normal, just Unity prefab.
Because Unity has references to all this stuff, so you don't need to send anything but the prefab.
Exactly. Which is really cool.
Yeah. So there we go. We got this, and now I'm going to do some code.
Oh, it works. Perfect.
Yep, and you just drag and drop in your yeah, it's already prefab, so you're set.
Wait,
and we can just spawn that in. whenever we need them. So things that we're going to need: public game object. And this will be
should it be reset to
prefab.
transform? Yeah. Okay.
And then what we can do here is we're just going to check for stuff. So we're probably going to want to cache our material reference. Var mat equals this. And then we can just say if mat is not already color, we're going to do 3 things. We're going to make mat equal color. And then we're going to spawn in the effect. So then we can just do VRC instantiate, spawn in our snazzy effect. So we're going to need our effect prefab.
Okay, what are we doing? Effect prefab? Did you make in laser gun? Did you make a new public variable called effect prefab public game object or
it's just game object? I'm going to call it effect prefab.
Okay.
Now we have that. And now down here, inside of us succeeding, right under all this, we're going to have this code. Or no, this code.
What the heck? Where did that come from?
Basically, instead of setting it the color right here, we're putting all of this material into a material slot. And then we say, hey, if this does not equal color, so if it's like white or blue or orange, so it's not green, then we're going to make this equal it, right? And then we are going to instantiate the prefab. And then we're going to make the prefab's position equal the hit dot point.
When did you write all this out of nowhere?
Just now.
Oh, okay. You just put var mat equals hit in front of there.
And then I removed the equal color at the end.
Oh.
Yeah. So
because you're going to set the color.
And then we just run this code. Now, we don't want it to actually be inside of a cube. So it's inside of the cube, the light won't work and the particles will spawn in the corner. So we're actually going to want to choose a point in between hit point. But I'm thinking actually what we could do is hit dot normal. And then this is the normal of the surface that the ray hit. So this is actually like an outwards arrow from the face. And then we can times that by 0.3 float. So it's only like a third of a non-cheese height out. And so it'll spawn on the face or a little bit off the face that we just shot at. So it won't be inside of the cube when it spawns in. So we're spawning it at the point, and then we're going to scooch it over away from the normal. Because the normal is just an arrow pointing out of the face.
Like, okay.
I'm going to walk you through this. So we have our material reference, right?
Yeah, material
so this
reference
is our material.
Mm-hmm.
If our material is not already the color, because we don't know if it is or isn't, but if it isn't the color, we're going to make it the color. And then we're going to spawn our effect. We then save the effect over here as a temporary variable. And then we're going to move the effect to where we want it to be on that exact same frame.
Okay.
Does that make sense?
Yeah.
And so now, let's save it. And make sure to drag and drop it into our script. And then we drag and drop effect into effect prefab.
Effect prefab would be right there. Okay, perfect.
And now if you hit play, it should just instantiate it. That's not supposed to
this
happen.
is cool.
Hashtag Minecraft XP.
I'm gonna stop the play. Okay, that was not what I wanted.
The objects.
That will destroy my PC.
Yeah, you might want to destroy them after spawning them. So maybe stop the play and let's destroy it. So prefab dot destroy.
The CPU time is 8, and it's only increasing. Wait, I want to see how far it can go. Oh,
Aaron,
the
you're gonna
CPU
crash
time
Unity.
Okay, bye.
Really? Let's see what my CPU performance is. Oh yeah, it's bad. Okay. Yeah, we gotta destroy those.
So let's destroy it after, let's say, maybe 2 seconds. I think that's enough time for it to do whatever.
Okay.
Just go-
Where in the laser gun? Oh, how come destroy didn't come up? Oh, there we go.
Mhm.
Okay. Let's see.
There you go. So now they should destroy themselves.
Oh, the light keeps the real-time light on there. That's bad. But also pretty cool.
So why aren't they changing? That is my concern currently.
Oh yeah, they aren't changing. Oh, it's because you removed the color variable, I think.
You think so?
Uh-huh. Remember how you had color at the end or whatever? Like on line 39. The variable mat equals hit dot collider, the mesh renderer material didn't have color in it. Or I don't know if
We
that's
should
true.
be able to just make it equal color here though.
Oh, But this says if mat is not color, do this.
Alright, let's make it.
I don't know if that's true. I don't know if that is true. Oh, mesh.
Mesh rend. So mesh rend dot material. It's not equal color. Maybe we got to do it like this because color is like a variable like 1, 2, 3, 4, and 5 rather than an actual object. So I think this is our problem. And I think this will fix it.
Mesh rend dot material isn't working for me. Mesh rend dot material.
Yeah, you got to remove the dot material at the end because we're not getting the material anymore. We're getting the renderer.
Mesh rend.
So get rid of dot material on the line above it. So now we're getting a reference to the mesh renderer. Yeah, because material. All right, so Aaron, I gotta tell you about different data types.
Okay.
Let me get this out.
Yeah.
So we have different data types in VRChat and Unity and all that. So over here we have our super snazzy mesh renderer, right? And inside this mesh renderer, it has let's say we're going to be using examples that you would already understand. So like this is a 1, let's say, right? Now our script over here, this is going to give me anxiety. There we go. Yeah. Over here, this guy, we want to go over here and say, hey, make this guy in here. So what we do is we go and we find our mesh renderer. And then what we do is we copy this 1 to here. And then what we did on this line here is what we did is we said, okay, this 1 should equal 2. Now through doing that, this guy over here hasn't actually been changed.
Yeah.
That was our problem.
Okay.
So what we wanted to do instead actually was rather than making this 1 equal 2 over here internally in our system,
yeah.
What we wanted to do is we actually wanted to take note of the actual game object, this guy. And we want this object over here. And then reach inside of his 1 and then change this 1 to equal 2.
Okay.
Does that make sense?
A little bit, yeah.
And that was our problem, is this we weren't actually affecting that. We were affecting a temporary variable rather than affecting the actual one.
Oh yeah, so kind of yeah. Okay, so
Because yeah, this wasn't a reference. This was like a number basically.
yeah. It was like saying, yeah, you turn down that street to get to their house instead of name a street to get to house.
There's so many particles. As you can see, this is the most optimized script that ever existed. You can hear the whirring of your computer.
You know what's funnier?
Mm-hmm.
I can hear mine whirring by just showing this as a video. And I'm running VRChat on it.
I'm just gonna remove the light. It's.
I don't think it would be that bad if it
that bad.
If it didn't do it every single time it hit a green thing, only when it changed it is what I wanted. So let's look at this and let's see what's actually wrong.
And what if we give it like
yeah, so whenever it changes it, it'll throw it. Yeah, that would be better.
Yeah, so I'm not sure what I have wrong here.
Hi, DG.
Hi, I'm just seeing what's happening.
Hello there. So if our material equals color, does not equal color, it should work. Why isn't it?
You could also do that it only spawns like 10 particles every time.
Let me do some testing. Does this fix it? Nope, it's still spamming it. Why is it instantiating it? Seth, you have any idea? So if we're hitting something, then we get the mesh renderer. If the mesh renderer's material is the same as our material. I don't understand this. Okay, I'm gonna try something scuffed. What we're going to do here is rather than changing the material, we're going to do meshrend.gameObject.name for now. And we're going to make that equal just some random string of, let's say, 1. Or, yeah. So if this equals 1, and if it does not equal 1, no, wait, if it does not equal the name of 1, set its name to 1. So this will just rename all the game objects. And if they aren't named that, then we'll do the effect. So we're just storing we're just storing the name as a variable.
Is this safe?
Hello, I'm back.
Hi, we're trying scuffed things, Seth.
What are you trying to do?
Earlier we were saying if the material equals color, do a thing, but it was still doing it every frame, even when the materials match. So I'm like, I'm just going to rename them and check if the name, just to like for debugging purposes. Yeah, now it works. So this is a slightly scuffed way of doing it, but it works. So Aaron, yeah, try it.
It works, but it's super scuffed.
Shh, we're programmers. We make things work, not make things optimized.
That's not true. That's what programmers do. They make things optimized.
Now, just don't worry about it when everything in your hierarchy is renamed to 1 during runtime.
I don't even think
give it
it'll...
a tag instead.
Oh, it's not working anymore for me. How'd you, what did I do wrong? Yeah, it's not working.
I saw them spawn in. I saw a little green light at the bottom, so maybe you just didn't teleport it. Here, let's mess with it again and let's see where they're spawning. Yeah, I saw the little effect.
They're not changing colors.
Click on the cubes, see if they're renamed.
No.
Any of them named 1?
Nope. I think it's something in the code I didn't have right.
Yeah, you might have missed a part or a line. Here, you want me to just give you all mine? Replace the entire class of laser gun with this.
Okay. Let's see.
That's all my code, exactly. Yeah, so everything from line down. There we go. Put that in, save it, and let's see if that works. Now let's check it out.
Pickup use down doesn't have anything in it.
That's because you don't even have a VRC.
A what?
Blessed if you can't use sign email. Don't worry about it. Just go.
It's working. Don't worry.
It works. That's what's important.
It's gonna rename all these objects to 1.
And if its name isn't already 1, it's not going to do anything.
No, it's not doing anything.
Look if the script broke.
We have to make sure all these objects are plugged in.
I got a pee, BRB. Hello.
Oh, you're back.
Hello.
All right, so let's look at what broke because I'm seeing some errors getting thrown. Aaron?
Yeah.
You
Okay.
So let's look at it.
Oops. It's saying
Go to your inspector. Nope,
right
you
here.
have to leave it playing so we can see which script broke, Aaron.
Oh.
Because it works the first time. See? But we don't know why it broke.
I'm going to leave.
Which causes it not to work the second time. So you have to go into the inspector and show me the script that isn't working. Which is why I actually like having them as separate scripts, because then you can see which script broke.
Oh, okay.
Yeah, it looks like the nozzle script broke.
Hmm.
Looks like it doesn't have a reference to the line renderer.
Oh, mine
Yeah, so
fell
there we
out
go.
when
Now we figured out the problem, and
that
we
was
could
easy.
figure out which one was broken, because there's like 3 scripts and only one of them broke. So now move it around. The ghost. And it's scuffed as hell, but now it works. And that's what's important. And
So it is
Yeah, and this is actually a little better than what I did for my they're all 1.
So like, how do we make it so an object appears once the whole walls are painted? So when all the walls are
there's
painted.
2 ways of doing this.
Okay.
The naive way would be to like go, okay, I'm gonna have a script iterate through each and every one of these cubes. Each time I change one of the cubes to be renamed to 1, and I'm going to see if all of them are named 1, right? And you do this 1 by 1 by 1 by 1.
Yeah.
That way would work, but it would be very CPU intensive.
Yes.
Right? And a way that I think would be better is to just count the number of cubes that we've hit. So every time we rename a cube to 1, we have an integer on our script that says, I have painted 1 cube. And then you paint another one, I have painted 2 cubes, right? And then what we can do is we can look at the parent object of all these cubes, and then we can do transform.childCount, so we can see the number of children that are under that. And if those 2 numbers match, I have painted the number of cubes that are equal to the number of child objects of this transform. Then unlock the door. So that way we don't have to check 500 strings, we just have to check 1 integer if that equals another integer. By the way, Aaron, this is actually way more optimized than my Udon Sharp thingy, Game of Life.
Yeah.
Because in my Game of Life script, I had basically the same thing where I had to replace a bunch of materials on a bunch of cubes. Now, the problem with this is, I wanted to save data inside of the cubes, in each one of those cubes. So my solution was, I'm just going to put a class in every single one of those cubes. So that one Game of Life program has like 255 different Udon Sharp scripts. Just on each and every cube. And this way, we don't have to put an Udon Sharp script on each of these cubes. We can just use the name as an integer. Which is scuffed, but it's more optimized than putting an Udon Sharp script on literally every cube. So this, yeah, I'm using the knowledge I gained from my
Yes, let's put it to action. I'm ready.
Yes. So we are going to be making it so we are going to have one more variable, public int, and this will be number of cubes painted.
Okay. Yes. Okay, number of cubes painted. Where do we put that?
Yep, and now we're going to want a public transform. And then we're going to call this cube's parent. And this will be the guy that contains all our cubes.
Okay.
Now what we do is every time we paint a cube, so we're probably going to put it right here because this is where we, actually paint it. We're going to say cube parent dot, and then let's say child count. And this is what we're going to be accessing. This is the number of children that are under that one thing. So what we can do then is if child count equals, and then what we're going to want to do is we're going to have painted cubes, or number of cubes painted, I mean. If that equals, then what we can do is, unlock a door. So what we can do here for this part is we're going to want number of cubes painted to go up by 1. So we'll do plus plus. And this just means increase it by 1. You'll see this a lot in for each loops. And so what we do is we increase it by 1. And then if these numbers match, Then we're going to just unlock a door here. So I guess we'll just have a public game object, or I guess set active or set item active.
Set item active. Okay.
And then we'll put this in here, and then we'll just say dot set active true. So now what we can do is we can have a sign that says "You win" appear before the player after he has painted the same number of cubes that are a child object of the transform that we're referencing.
I didn't know you can reach into the children and count, see how much are in there.
Yeah, we don't need to like keep track of them this way. We can just say.
Yeah, because if this was an update loop, would take forever.
Yeah, because this is like a bajillion cubes, and now these cubes literally all they do is render on your screen and hold a collider, and they're even like GPU instanced, so they're super optimized. Because we have, I have 511 cubes right now.
Yeah, so this would be the prize. So I'll make like this the prize that appears.
I love the sphere. This is beautiful. That sphere is going to be my prize too.
Okay, so let's.
So you win sphere. Yay!
Let's do it.
And I'm just going to turn this off. And now in my my little turret nozzle script, I can do the set item active and put the sphere in there and make the cubes parent be the one that I called cubes. So I dragged in the cubes parent, and then I dragged in the sphere, and now it should all be set to be ready for being snazzy.
Oh, it's not working. Oh no.
That's because you probably forgot to drag and drop something in.
Oh, yep, I did. For the nozzle, set active
Cube
item
parent.
would be this.
Yep. And then find yourself the cube parent.
So this should be turned off, or does it not need to be turned off?
It doesn't need to be, but I would say you do for your use case, since it being on and then you turning it on makes it do nothing.
Oh, okay.
So yeah, find your nozzle and then drag and drop in your cube parent.
Oh, this is
and
nice.
Then we can reach inside of that and count the number of children inside of it, and then say if I painted the same number of cubes as this has child objects. So now if you hit play, and then you can work on painting.
Oh no, it broke again.
Let's look at the broken script then.
Is it this?
Yep, it looks like it broke. Yep, it doesn't have a cubes parent.
What?
Yeah, I think you dragged it into the wrong thing.
Oh.
And now you want to drag and drop in your set active thingy.
Oh yeah, I did have it on the wrong. Oh, there we go.
Cause no reference values break udon. There we go. So yeah, now you grab your little ghost thingy. Yeah, look at all these.
Oh, so I have to make. Oh, now I have to paint all of them. That's gonna be so annoying. So how do we know? I think
it wouldn't be as bad in game. How do we know when you have way more accuracy?
Yeah. How do we know when the thing teleports back to you?
What do you mean?
The IK system. How do you know that that's gonna teleport?
Oh, it's just on drop. So when you let it go, it'll just teleport back to it. That already works.
I don't think we have it in the code though, because if we look at it like.
You want to go to the handle code. This is the laser gun code here.
How come there's on pickup use down?
Snap on drop code. That's it. So on drop. Make sure to actually set that to a override, by the way.
Where? Public virtual override.
Override.
What
virtual
override?
means people can override it. Override means you're overriding a virtual.
Okay.
Here you go. Now it works.
How come there's this piece of code right here then?
Because I was thinking to fire only the laser when you hold down the trigger, but then you're like, nah.
Oh, can we get rid of this?
Yeah, you can get rid of it.
Okay.
And now you have a snazzy laser gun.
This is awesome.
Yes,
I'm gonna get.
People can paint stuff.
This is gonna be awesome. Wow. I didn't realize, now I know, like, understand that, like, adding one little thing to it could make the code go so much more complicated.
Yeah. Honestly, this is the type of thing you'd see in Evolve Dance Arcade.
Yeah. And this could be like a really cool puzzle.
And the way this code works is that you could actually just rip the code that we did make, the laser code, off of the actual turret and just put it on a gun, and you don't have to rewrite the laser gun code at all.
Yeah.
Because they're all separate parts. They're not all one big script. Ain't that nice?
Will it still run if it starts on off? So like so this laser isn't running the whole time. Okay. That'd be cool. It sounds gonna be really cool. Whoa, it works! What the heck?
That's because the number of cubes you painted is equal to the number of child objects under the transform.
Can we turn off the line renderer at the same time the cube that's turned on, so like it shows that you did it?
How would you do that?
We're gonna find the line renderer right here, right?
Yeah.
And then we're gonna do this dot set active false.
It is not a game object, so it does not have a set active.
What? Then what does a line renderer have?
Enabled.
They hate us.
And then you have to make that equal something. Because that's how it works. Yeah. But look at that, Aaron. You're a master at code. You knew the answer to that. I was expecting you to make a game object reference, but no, you did it all optimized like.
Yeah, so then you know.
So yeah, now the laser will stop and you're like, yeah, I painted them all.
Ooh, what if we wanted to do a sound effect too? So if we wanted to make a sound get activated,
you could put a sound effect on the sphere, so when it turns on, it'll just play it.
Genius.
You could also just get a reference to an audio source and just do audio source.play. Either works.
Oh, no one's.
No, you are a master coder, Aaron. Feel special.
Yes. That was fun.
And there you go. Well, one object, 4 hour.
Yeah, I think we should do this every week, but I think we should realize like the scope. Because I didn't realize how long that would be. I'm happy because I learned a lot. But for your sake.
Well, it's just like.
I think, yeah.
Oh, I want to paint this one thing, and then we paint it. And then you're like, ooh, I want to add one more thing, and then you add one more thing. Oh,
I thought it would be like an IK system would be like a component like IK, and then it would make you do that. But I didn't realize you had to make it teleport to it when it goes away.
Our IK system is a negative symbol and one line of code. Because our turret is literally just look at, but then we want it to snap, so we have to add these 4 lines of code. So it's not a lot of code, but it is something that you have to think about and puzzle out how you want to do it, so that it all works.
Turret IK test system. And then you can export it as a thing. I'll make the line render look pretty. The line renderer. That was sweet.
And to make a gif of it and flex on everyone about how cool I am.
Yeah. I'm gonna go take a break. I think you take a break too. That was fun.
I'm really happy with this.
Yeah, I can use it as a puzzle. I can't believe we did that.
Mm-hmm.
Templar.
Yes.
Yep.
Could you send me a link for that program what you used?
I'll
What program?
see you later. Bye.
What you used for those for the entire programming session, not the programming session, the visual session. I'm being dumb.
Oh, do you want just like the entire thing as a prefab? Is what you're saying?
The actual program, because I don't have one where I can do this kind of stuff.
Oh, you don't. I use Unity and Visual Studio.
Oh, I'm going to search on it.
What?
I'm being a Linux user and I can't use the VRChat kind of things. But it suffers to make words and skins, avatars.
Versions and skins?
Words and avatars.
Oh, you don't know how to make worlds and avatars?
Yes, and I can't use those programs too because I'm a Linux user.
Why don't you have a Oh my goodness.
Windows?
Yeah, a Windows VirtualBox.
I don't really know. Maybe
I'd
because I don't
recommend
know
getting
how
on
to run
that.
it. I mean, I do have
There
Vine.
are Linux VirtualBoxes as well as Windows VirtualBoxes, so you can hop between them as just running like a little subdirectory of it.
Yes.
That's what I'd recommend.
I'm afraid that my computer is not going to handle it. I mean, I only have 8 gigabytes of RAM.
I wish I could understand you.
I wish to. I wish I could talk.
Talking is hard.
Especially if you don't know pretty good. Well, I messed myself up really bad.